Dan Olds, and I'm here in Shanghai for ASC24. I am a long-time observer of all things student cluster competition, and
Mhm.
we have an interview set up
Yeah.
with one of the experts behind one of the tasks for the students. And you know what? You just told me 15 seconds ago how to pronounce your first name. And you know what? I forgot already.
Yong Hua.
Yong Hua
Yeah,
Lin, how
yeah.
are you today?
Good, very good. Thank you.
Good, good, good. And your application, it has to do with large language models
Mhm.
and making inference faster, right?
Yes, right.
And that's a huge focus of attention for the industry now. Uh, Everybody, it seems like, wants to have their own LLM, and
Yes,
inferencing is going to become a much bigger workload, I think, than most imagine, right?
right.
And do you think people are paying enough attention to that?
Depends. Um, for example, if just a user, if just a user of ChatGPT, they
Hmm.
may not pay so much attention on that.
Yeah, and I'm actually speaking more
Um,
about
but
the
if for
organizations that are putting
enterprise,
up their own,
they're
yes, for
going to
enterprise.
deploy the LLM by themselves, yes, that will be the painful things, and they need to pay a lot of attention on the how to reducing the cost.
Exactly. And making sure you're doing it at the right precision. Um, and I think that for most, it's I don't think they really understand how computationally intensive inferencing might be or might not be.
Right.
And doesn't that depend on the model that they're using and the complexity of it?
Yeah. Actually, it really depends on the model's complexity.
Hmm.
For example, the model, even that we call it the large language model, but it has different size.
Yes.
For example, you might have the model only have several billion of parameters, or you might have the model have more than 100 billion parameters. Then it will make maybe
Yes.
10 times or 100 times difference. Yeah.
And so it's really the number of parameters that makes the difference, not the computational complexity of the model like it would on machine learning on the training side.
Okay. Actually, if we talk about the inference
Hmm.
side, it's not directly connect to the complexity of the training side.
Okay, that's what I was asking.
Yeah,
Okay.
because the complexity of the training side, it will depends on for example, the size of the model and also the training data set of the model.
Yes.
If we use a much bigger training data set to train the model, then the cost for the training side will be much higher. But once the model has been trained, for example, for 7 billion model or 700 billion model, then it will depend on the parameter of the model, the number of parameters of the model. So this is one side. But of course, the other side is the hardware,
Yes.
the device, okay, right? So for example, for those smaller model, for example, those model with just several billions,
Hmm.
people might not use the server on the cloud.
Hmm.
They might, or even they can use the device, GPU device,
Hmm.
for the consumer market. It's okay, still okay to run the model. And
Mm.
then the running cost for the inference side will be much cheaper. So it also related to the underlying the technology like the hardware, and also there's also some company, they are developing the acceleration technology to help the inference to run the faster. For example,
Mm.
VLLM, this is one of the very famous open source project. It will
Hmm.
help us to accelerate the model to run on GPU much faster. So there's also some way to help to impact the cost of the inference.
I see. And once the model is trained and it's in production, and of course you know the size and all of that, is the inferencing requirements for computation, is that predictable? But I mean, it's going to vary on demand, of course, but it's predictable. I mean, you'll know how to scale it, in
Yeah.
other words.
Okay. Since each request, they might have different length of the sequence. For example, if your request, the prompt is much longer,
Hmm.
then or the reply is longer, then the cost for this single request will be higher cost. So
Okay.
we can predict this for each token's cost,
Hmm.
But for the request, you might have different size of the token. You might ask a longer question or require the LLM to reply a longer sequence. Then the cost will be different.
So the size and complexity of the request is going to make a significant difference then in
Yes,
how
right.
much computation.
Yes, right.
Okay, that all makes sense. And again, like we said before, I don't think most organizations have really factored that in because a lot of them haven't even really settled on what model they're going to use.
Yeah.
And what are you seeing in terms of enterprise types that are adopting LLMs? What size model do you see them gravitating towards? I mean, they don't all need 700 billion parameters.
Right. Okay. So today, for example, if we say just a simple dialogue,
Hmm.
like to help the human to do the assistant to sell some kinds of product, that
Hmm.
kinds of
Like
chatbot.
customer
Yeah.
service type
Okay.
things.
Yeah. Right. For that for that kinds of application, maybe we just need to have the several billions
Hmm.
parameter, the model for that size, and the enterprise can use that kind of size to they can use their own the enterprise data to fine tune that model.
Hmm. Okay.
Or for example, in our vehicle, now the vehicle enterprise, they also want to put the chatbot into the vehicle, and to do some when we are driving, so that we can have some assistant. Yeah. So that also work well with this kind of smaller size. Okay. But if we want to have the model to serve more complicated scenario,
Hmm.
with more logistic thinking, logical thinking. For example, in more complicated analytic for the finance or commercial scenario, or even for the lawyer,
Sure.
that kind of scenario require more complicated logical thinking. Then we will need to have the model with the size around the several the tens billion parameter, that kind of size, tens billion parameter. Yeah. And enterprise, they can download these kinds of open source model and use their own domain data to do the continued training and fine tuning to get some in domain the model. And that those kinds of industry domain model will have can serve more complicated scenario.
And then also, if they're trying to support queries and prompts in different languages, like
Okay.
Chinese and English and
Right.
Italian and all of that, that's going to add some load as well, right?
Right. They if they want to serve a new kinds of language, then usually we need to add first we need to have the data set for that kinds of language,
Hmm.
and use the data set, that language data set, to do some fine tuning, continue training for the model and fine tuning. Then this model can support a new kinds of language.
Well, let's get to the competition. What's the specific task that you laid out for the students?
Okay. Actually, we asked the student to try any kinds of method to speed up the inference. Yeah.
And they've been busily doing that. I've been out interviewing them, and some have tried, 10 different models, tested them, and gone out and really looked hard. And it's been a good challenge for that. So you're looking for then the fastest speed up over the test case for
Uh,
inferencing? I mean, you gave them a data
yeah,
set, I
yeah,
assume,
yes, right.
and that takes a certain amount of time to
Yeah,
inference. So you're looking for the best speed up
you're right, right.
versus that.
Yeah, right. Yeah,
Interesting.
actually we give them the data set, yeah, and so that we can have a baseline.
Hmm.
So we will see after their practice or the different kinds of trial, how the speed up versus the baseline. Yeah.
So summing up, let me ask you this one though. Now, the students won't see this interview until after the competition's been over,
Mm-hmm.
and I won't tell. So it's
Mm.
just a secret right now.
Okay.
Is there any particular method or secret that will lead them to the right um, speed up, the best speed up? Is there
Mm.
some secret they need to discover, or are there multiple ways to get to what you think will be the best result? I mean, do you know what the best result could be?
Okay, yeah. Actually, this is open challenging. We actually also the exploring the what is the best way and what is the best result. Actually, we don't know the where is the best result. So this time, really, this is an open challenge. We want the student to try any way to do that.
Yes.
Yeah. For
So,
example, they
mhm.
can even change some hyperparameter of our model
Mm.
or so change some different kinds of parameter to try it. Yeah. Um, so
So it's wide open. Whatever they can do,
yeah, very open. Right.
I like
Very
that.
open. Yeah, yeah. Actually, or even that they can they can use some way to optimize the prompt, for example. So there can be different way to do the these kinds of speed up. And so they can use different way to speed up, to do the
Hmm.
speed up. And and we will evaluate the result use the same benchmark. Yeah. So they reach
And
the benchmark's result, then we'll see which one can get the result with the shortest time. Yeah.
it's going to be very interesting to see how they do. I'm looking forward to seeing the results of this one.
Yeah.
So
Right.
great job on putting this
Okay.
together and participating in the competition. I know the students appreciate it and they're excited by it.
I'm glad to hear that. Yeah.
And it's they're learning a lot, which is what we want.
Yeah.
So there you
Exactly.
go. And thank you for taking the time for this. Really
Welcome.
appreciate it. And keep doing this. Do it again next year because they really need this experience. So thank you
Yeah.
again.
Right.
Thank you.
Welcome. Welcome.